All right, hello and welcome back. We are in 11.5. We have 11.6 and 11.7 left to go. We'll be finished this week and a test will be next Tuesday. This section deals with understanding about cones and pyramids. Okay, so finding the volume of cones and pyramids. Well, first of all, part of the issue is just finding the formula. So knowing the difference between a cone and a pyramid and a prism and a cylinder. So we're looking for things that come to a point. But the work is done the same way. The first thing you want to do is draw the shape of the base. Okay? So the shape of the base is important because that tells you what area formula you're going to use. Okay? Shape of base. Why? Because they don't give you that formula. That's the part that changes. Once you figure out the shape of the base, it's the area of the base times the height of the figure. Okay? So it's no different than what we had done in the past, except many of you don't draw out the shape of the base, and then you write the wrong area formula that goes there. Remember, if you draw the shape of the base and it has right angle marks, you already have base and height. You don't do 1/2 perimeter times apothem. You can, but you're going to be doing twice the amount of work for what you're supposed to do. All right? Now, the difference is the volume formula is the same. Then we're going to write the formula. And the volume formula is the same for all shapes. It's just what the area of the base is that's different. So the volume is 1/3 the area of the base, this is the thing that changes, times the height of the figure. Okay? Height of the figure, area of the base. Now we draw the shape of the base because the height of the figure will be the only number I didn't put on my base. Right? So we want to make sure that we understand which formula we're using. Remember, the other one was just area of the base times the height of the figure. So that's what makes cones different because they come to a point. It's only 1/3 of what was there. Okay, so let's do a sample problem. Let's say a sports arena is shaped like a pyramid. Okay. It has a base area of about 300,000 square feet. So they're already giving me the area of the base. So I don't have to draw the shape of the base because they're giving me the area of the base. So I would write down and I try to draw my shape. They said it's a sports arena. Okay, so I just go ahead and draw a square or a rectangle. But they gave me the area of this base. They told me it was 300,000. Okay, so I already have the area of the base. For volume, it's 1/3 area of the base times height of the figure. Well, they've already given me the area of the base. So it's 300,000 divided by 3, and then we're multiplying it by the height. And as I keep reading, they tell me the height is 321 feet. All right, then the rest is calculator work. Now I will tell you, you can make it easy on yourself. I can do this, and then this becomes 321 with 1, 2, 3, 4, 5 zeros. Okay. It's a shortcut for multiplication. If you don't know those shortcuts, use your calculator and you'll get the same answer. All right. Now what can change? There will be times where they don't give you the height of the figure. And what will you need to do? If you're missing the height of the figure, correct. You're going to have to do right triangle work. So that means you would draw your right triangle, and this is always your height of your figure. It's always been that. Okay. And this is either half the side, or it might be your apothem, depending on what the shape is. That's because the apothem is sometimes half the side in a square or a rectangle. or excuse me, square, correct. In a regular square, the apothem is half the side. And then this is always my slant height. Well, the problem is when we're dealing with a pyramid, we're not using the slant height. We have to use the height of the figure. So sometimes they give us a slant height instead of the height of the figure, and we have to do Pythagorean theorem to find the other measurement. As you look in problem number 2, they give you a rectangular pyramid or a square pyramid. So what I would do for this is example 2, I would have drawn this, and I would have gone volume equals 1/3 base times height, because that's the area of the base, times the height of the figure, which will be the only number that's not on my picture. So I know this was 40 by 40. And this is my base and height. So I have volume equals 1/3. And then we have 40 times 40 times, and I need the height. Well, the problem is they don't give me the height. They give me the slant height. So I do my right triangle work, and they give me slant height is over here. And this is half of the side or the apothem. And in this case, the apothem is half the side, which would be 20. So now I do my Pythagorean theorem work to figure out what this measurement is. So that would be x squared plus 20 squared equals 25 squared. Okay. This is 400. This is 625. Okay. Minus 400, so that gives me 225 equals x squared. Square root it, it gives me x equals 15. So if x equals 15, now I go over here and put in 15, and then the rest is calculator work. Oh, and let me move that up. I apologize. Okay, so again, I do the right triangle work. I need the height of the figure. I know that's the height of the figure. So I have to do right triangle work to find the height of the figure. Good job. Now, the only thing that makes the volume of a cone different is the fact that this formula will always be pi r squared. The area of the base is always pi r squared because in a cone, the area of the base is always a circle. So it makes it easier because it's always a circle. They have a separate formula that puts it as a circle already. But are the formulas any different? No, it's the area of the base. The base just happens to change to a circle, so we can put in the area of a circle. All right, you do got it number 3, and then pause it, finish it, check it, then let me know if you have any questions when you come back. Okay, good job. I'll let you know what the got it answer was. The got it answer is 77 feet cubed. Okay, and the volume of the original TP is 8 times the volume of the child's TP. Volume is always cubed. Hopefully you understand that volume is always units cubed, just like area was always units squared. And we'll get into that more in 11.7 because that's more important. But if you double everything from the beginning, that means the area gets 4 times bigger, but the volume would get 8 times bigger. Notice the difference between regular area and volume will never be the same number. If you double the sides in area, or if you double the sides regular, you make the area 4 times bigger, and you'll make the volume 8 times bigger. Because this is 2 cubed, and this is 2 squared. Okay, so paying attention to how volume works is important. Okay, and you also have to read the questions because a lot of times they'll ask you, round to the nearest decimal, which means you have to get rid of pi, and then sometimes it says leave in terms of pi, which means pi is supposed to be part of your answer. All right, go ahead and pause the video then and work on problem 4, the got it 4. An oblique is done the same way. The difference is with an oblique, it's just kind of off center. So you're still looking for this right angle mark because that will tell you what the height is, height of the figure. So you're still looking for this. It's just not always right in the middle of the center anymore. Sometimes they put it outside the figure. Sometimes they put it inside the figure, but you're still looking for that right angle mark. All right, so now do the got it problem. Pause the video, and then I'll give you the answers once you've finished. All right, good job. The got it answer for A is 144 pi meters cubed. And the second answer is 452 meters cubed. Correct? And then B is they are equal because both cones have the same base and the same height. They may not look the same, but they do have the same base and the same height. All right, that was really brief. It's not a really hard concept. Hopefully you're ready to go when you come back tomorrow. Thank you very much for watching.